This integrated 1, chapter 5, we're going to continue on with arithmetic sequences. So let's kind of pick up right where we left off previously, and then we'll make some changes. So we want to know if the sequence is arithmetic. So that's the first question. If it is, then we're going to go through and state all of these things. So the first thing we need to do is even determine if it is arithmetic. Remember, arithmetic means that you are adding or subtracting the same number from one term to the next. So if you take a look at this, it's addition or subtraction. If we want to go from 7 to 7.5, I believe that's an addition of 0.5. Okay, so if this is arithmetic, every single one of them has to be plus 0.5. Okay, 7.5 plus 0.5 gives me 8, and 8 plus 0.5 gives me 8.5. Okay, this is arithmetic. So, yes, this is arithmetic. All right. Next thing, now we need to start going through our list. So I'll kind of highlight as I'm going. So is the sequence arithmetic? So that's my purple. Yes, it is. All right. Now we need to be able to identify a few things. If it is, we need to state the common difference. Okay, so remember, that is the thing that we keep adding repeatedly. So for this, the common difference is plus 0.5, or we can just say positive 0.5. So I understand that it means that it's addition. All right, moving on. Okay, next thing we need to take a look at. Let's see. Find the 0th term. All right, so remember, I'm going to kind of back my way up here. Let's get rid of this A in front, because I do want to go backwards for this. So I need to figure out what number, when I add 0.5 to it, gives me 7. And I believe that's going to be 6.5, because you still do have the plus 0.5 there. All right, so our 0th term is going to be, well, whatever is in front. So what is the number that is immediately in front of your list? And in this case, it is 6.5. Okay, the explicit equation. Now, keep in mind, too, you guys, you don't always get asked for all of these things. Just kind of loading up our questions with a whole bunch of stuff at once. So the explicit equation. All right. The explicit equation is the T of n equation that we did last class. So explicit equation has the same basic form as y equals mx plus b, but we use T of n instead. And it is dn plus c. Okay, so let's start plugging stuff in. We're going to leave the T of n and we're going to leave the n. Now we're going to take the common difference, which we know really is the slope, and we're going to put that in front. So that's d. And then we're going to identify the 0th term, and that's going to be our c value. So plus 6.5. Okay, there is our sequence, or our explicit equation. All right, let's move on. The 31st term. All right. So to find the 31st term, we're going to take our explicit equation, and everywhere there is an n, we're going to put a 31 in its place. Okay, there's our 0.5 from the common difference. We're going to plug a 31 in for n, and then bring down the c value, which is 0.65. All right, now I'm just going to grab our calculator and type it in. So if we do 0.5 times 31, and I'm just going to type it all at once, plus 6.5, that's going to give me 22. So again, what this says is that 31 is the location in the sequence, and 22 is the actual number in the sequence. So this is the number in the sequence. Okay, so really kind of just what we did last time. All right, let's move on. Question 2, same directions. Okay, this is a perfect opportunity to pause the video, See if you can answer all of the stuff that we did on the previous slide. So determine if it's arithmetic. If it is arithmetic, then do the list of things. If it is not arithmetic, there's nothing to do other than say not arithmetic. And then we move along. So why don't you see if you can answer this question. Okay, this one kind of stalled out of the gates immediately. This is not arithmetic because I'm not adding the same number repeatedly. It's not just that you're adding, it has to be the exact same number. So since adding 3 is not the same as adding 4, which is nowhere near adding 5, this is not arithmetic. This question's done. Okay, so let's change this up a little bit. So now we're being told it's definitely arithmetic. All right, so I know this. I know that whatever it is that I am adding, oh, and we need to change this because it currently is not. So let's write something else here. Okay, so now that's corrected. We actually have an arithmetic sequence. Couldn't really do it if it wasn't. So here we've got our arithmetic sequence. We can even do a quick check on it and see that this is continually adding 4 every time. So same number being added. Okay, now I'm sold that it's arithmetic. What I'm trying to do is I'm trying to figure out what term has a value of 92. Okay, what term? Okay, the term is always going to be n. So what term, that's the question, has a value of 92. Okay, so basically what I'm being told is that I know there's a 92 in the list. I'm just trying to figure out what location that is. Okay, so what term? N has a value of, okay, 92 is actually in the list. All right, well, I think we need to write the equation here. So let's go ahead and write our equation. So we know the common difference is 4. So D is going to be 4. I can back up to find the 0th term. So let's go ahead and do that. So back up to find the 0th term. All right, if I went backwards, I think this is going to be a 0. Okay, so that means that C is 0. All right, let's write our equation here. So using those two, I know that T of n is going to be dn plus c. Plug the stuff in. So T of n and n, plug in the d part and plug in the c part. Okay, well, you guys know with adding and subtracting, we really don't need the plus 0. So I'm going to write my T of n equation as 4n. Okay, so I'm going to use that. Now I'm going to go over back to the question. What term n? Okay, so I'm trying to solve for n. When T of n is equal to 92. All right, let's go back to our equation. I'll actually bring it over here. So I know I've got T of n is equal to 4n. All right, I'm going to take the T of n and I'm going to replace it with 92. So I'm going to replace that side completely with a 92. So this is going to be 92. And then drop your equal sign and drop the 4n. Okay, let's solve for n. So there's our equation. I need to divide by 4 to get the n by itself. 4 divided by 4 is 1, so that's going to cancel. And then 92 divided by 4 is going to give me 23. So basically, I would say that the 23rd term in the sequence is the number 92. So if I were to list it out, not that I'm going to, but if I were, I would do 4, 8, 12, 16. I know the next one would be 20, 24, plus dot, dot, dot. I would eventually get to 92, where that n value is 23. So again, remember, n is the location in the sequence. 92 is the actual number in the sequence. Okay, here we go. Another question, just like the last one. So we know this is an arithmetic sequence because we're told that it's an arithmetic sequence, which we can check. If we take a look at this, it looks like to go from one to the next is minusing 3. And it's the same number repeatedly, so that's good. What term, okay, n, so what term, so what actual location is going to give us a value of, okay, so this is t of n is equal to negative 159. All right, well, let's write out our equation. So I know that I have my common difference is going to be negative 3. So let's go ahead and write that down. So my common difference is negative 3. All right, let's go backwards and figure out what the 0th term would be. I think that's going to have to be negative 18. Okay, so that's C. All right, let's actually write this equation now. So using those two things, we know t of n is equal to dn plus c. All right, let's carry our t of n down and our n, and then let's slide everything in where it goes. So d is negative 3 and negative 18 for c. Okay, now we're going to use that equation. So I'm going to bring it over here. So t of n is equal to negative 3n minus 18. Okay, we know that t of n is going to be equal to negative 159. So let's replace that. And then drop everything else straight down. Okay, and let's go ahead and solve. So I'm going to add the 18, trying to solve for n. Those cancel. Drop the negative 3n straight down. And let's do negative 159 plus 18 gives me negative 141. I have to divide by negative 3. Negative 3 divided by negative 3 is going to cancel. Okay, let's divide here. So when I divide negative 141 divided by 3, I'm going to get 47. Okay. So basically what this is saying is that the 47th term in the sequence is, and the actual number we would see at that spot is negative 159. So again, if we started out with our sequence, we know that we would just keep subtracting 3, subtracting 3, subtracting 3. So the location that we would be at after subtracting 3 and landing at negative 159 would be 47. Now, it's important to note, and this is something that we talked about briefly in class, but n, since it is a location, and this was in our notes, since it is a location, n cannot be a negative number. It cannot be a decimal, and it cannot be a fraction. Because if you were in a list, so if you were actually like lined up, you can't be at a 1.5 location or a 2.7 location. That doesn't make any sense. Which leads us into this one. So we want to know, is 386 a value in the sequence? So I think what I'm trying to ask you is, if t of n is equal to 386, is n a positive, oh, it doesn't even have to be positive, a non-negative whole number. So no fractions, no decimals. Well, we won't know until we try it, so let's check. All right, take a look at this. Common difference looks like it's plus 12. All right, let's go ahead and write down that D is going to be equal to positive 12. Okay, let's go back. Let's see if we can find out what the 0th term would be, and I think that's going to be a negative 12. So C is equal to negative 12. All right, let's write our equation here. So T of n, again, is equal to dn plus C. Keep the T of n and the n. And let's plug the other numbers in. So the common difference was 12, and negative 12 is the starting value. Okay, well, let's test it out. So we're going to take that number that was given to us, that 386, and I'm going to plug it in for T of n. I'm going to drop everything else down, and I'm going to solve for n. So let's just see what happens. So this will be plus 12 on each side. Those are going to cancel. 386 plus 12 is going to be equal to 398. Drop the 12n straight down. Let's divide by 12. Okay, it's going to be positive because I know a positive divided by a positive, so I feel good about that. Satisfies the non-negative part. But now, if I type this into my calculator, I get 33.1666 or 33.1667 if I round. So I have to ask myself, is that an acceptable location in a sequence? No, not at all. So I would say since n is a decimal, which is not okay, then 386 is not a number in this specific sequence. So in this sequence. So just watch out for those. You want to make sure that it's even possible to do.